Okay, in this video I'm gonna solve basic integral problems, and by basic I mean there's no substitution or partial fraction, just nothing any crazier than that. Alright, so what we've got here is integral of 1 plus 3x squared minus 5x to the power 4 dx. So notice what we've got here is we've got plus and minus sign. So what we're going to do is we take the integral of each piece at a time. So to do that, so the marker got a little bit sticky here, weird, plus 3x squared. Actually, a lot of people, I know a lot of people would do the integral straight away, but what I'm going to do here is I'm going to do it the long part or the formal part, and then just for this example, the first one, and then we'll take the short part. Anyway, basically what we did here, we distribute the integral for each piece inside the parentheses. So what we've got here is integral of 1 dx, and you know the integral of 1 is x plus. Integral of the second part is 3x squared. What we do is, as the derivative, we'll leave the 3 out, the constant out, the coefficient of x out, and then we take the integral. And to take the integral, we add 1 to the power, so squared will become cubed to the power 3, and divide by the new power, which is 3. Same thing for the last part here. 5x to the power 4. Again, we leave the coefficient outside, and we'll take the derivative of x. So x to the power 4. 4 plus 1 is 5 to the power 5, and divide by the new power. And don't forget plus c, because, well, it's an indefinite integral, so we have to add plus c. What we do here is just simplify it. So the 3 would cancel the 3 out, and the 5 would cancel the 5 out. So we're left out with x plus x to the power 3 plus x to the power 5 plus c, and that's our integral. Notice what we've got here is, if you want to make sure that you've got the correct answer, simply take the derivative of your final answer, and if you've got the original form or the original equation or the original question, then you've got your answer correct. So if we want to differentiate x, well, differentiation of x is 1, so we get 1, so that's correct. Differentiation of x to the power 3, we take the power, the times it, and minus 1 for the power 3, 3x squared, and that's what we've got in the original one. Same thing for x to the power 5, 5x to the power 4, and that's what we've got. So that's a little trick. If you've got time, you want to check if you've got the right answers, just take the derivative back, because basically integral sometimes is called antiderivative because it's literally the opposite operation of differentiation. So yeah. Alright, let's do another example of integral. So we've got here integral of 3x minus 2 over square root of x. The first thing I do when I see a radical is change it to the power form. That will make our way to the solution a lot easier. So I'm going to write it as 1 over to the power 1 over 2 dx. Oops, sorry, I forgot the integration symbol. So a lot of people actually, when we see this, it's not like differentiation where we take derivative of each part individually and use the quotient long way rule. So I'm not actually going to do that, but what I can do is, or the partial fraction, what I'm going to do here is I'm going to do an algebraic technique on it. So what I'm going to do is distribute the denominator on this. So it's going to be 3x over x to the power half on its own, minus each piece individually, minus 2 over x to the power half, all dx, obviously integral. So now our problem looks a lot neater, and it can be solved a lot easier. So the first thing I do here is we simplify the x's together, so the variables together. So x to the power 1 over x half is 1 minus half is positive half, and leave the 3 as it is. Same thing for here. We x in the denominator, we put it up in the numerator by the opposite sign, so it's going to be, instead of x to the power half, it's going to be to the power minus half, and then dx. Always forget the integral sign, because I like to solve in a fast way. So yeah. So what I'm going to do now, finally, we got to that stage where we can take the our integrals. So as derivative, we leave the coefficient outside, and then we take derivative of the variable x. But here integral, not derivative. So what we do integrals, as you know, is we add 1 to the power. So instead of the derivative, we take 1. No, here we add 1 to the power first. So a half, if you add 1 to half, is going to be 3 halves. And then over the new power, not the old power, the new power, over 3 halves, minus, the same thing for here, we put the coefficient outside, and then we do integrate the variable. So minus half plus 1 is positive half, careful about the signs, over positive half, the new power, and then plus c, don't forget plus c, because as you know, we've got indefinite integral here. So now what we do is tidy that up a little bit. So we simplify it. What we've got here is, in the denominator we've got 3 halves, so basically it's saying times 2/3. So the 3 would go out with the 3, we're left out with equals 2x to the power 3 halves minus, oops, run out of space here. Same thing for here. Over half is basically saying times 2, so 2 times 2 is 4, and then x to the power half plus c, and that's your integral.